Let's go on to Chapter 4, The Alchemist. While the smelters of metal were after very practical things, the alchemists were fascinated with the mystery of nature herself. Why? Because they, exactly like philosophers before them and the modern-day chemists who came after them, loved a mystery, and the love of such knowledge drove them into the laboratory, the very first laboratories to be exact. But we must admit that they were after more than knowledge for its own sake. They were on a treasure hunt as well, looking for the secret by which base metals could be turned into gold. So in the end, some of the chemists had at least one eye on a profit which could be had from the art, but most, it seemed, wanted the knowledge of how nature worked more than they wanted the gold. As we have seen, the smelting of metals by fire goes all the way back several thousands of years before the birth of Christ. Alchemy, however, began in the 1st century BC, most probably in Egypt. Indeed, scholars believe that the chem in alchemy and hence in chemistry is from the Coptic word chem, which means the black land, that is Egypt, for after the Nile River rises and floods the land each year, it looks black. The alchemy probably began in Egypt makes sense. The Egyptians were some of the best metal workers of the ancient world. From Egypt, alchemy spreads to the Greek-speaking world of Syria and then to Persia. When Islam arose in the 7th and 8th century AD, it became the main bearer of alchemy. Indeed, the name alchemy comes from the Arabic. Al means the Arabic. So alchemy is the art of the Black Land. With the spread of Islam all around the Mediterranean Sea, alchemy spreads as well, and reached the Latin-speaking West in the 12th century. Of course, the alchemists knew the 7 basic metals, but they thought about them in a much grander way than the metalworkers. The alchemists associated each of the metals with a day of the week and a planet. Each metal also had a symbol, and the symbols were used for many centuries after. They were the first chemical symbols, and the alchemists wrote chemical formula with them. Now you know why wizards in the stories often have big hats with some of the following symbols stitched all over them. Alchemists were thought to be wizards. So gold is Sunday or the sun, silver, Monday, moon, iron, Tuesday, Mars, Mercury, Wednesday, Mercury, 10, Thursday, Jupiter, copper, Friday, Venus, lead, Saturday, Saturn. The relationship between the planets and the days, Sunday and Moonday, is obvious. As for the rest, the Saxon god Thor is the same as the Roman war god Mars, hence we call it Tuesday instead of Mars Day. The Saxon god Woden is the same as Mercury, so we call it Woden's Day instead of Mercury Day. Thursday was the name of the god Thor rather than for Jupiter. And finally, Frigg, the wife of Woden, took the place of Venus for the Saxons, and so we have Frigg Day or Friday. But what about the relationship of the planets to the metals? The sun is golden, the moon is silvery. Mercury, or quicksilver, was a good element for the planet Mercury, which seemed to move the fastest. Lead was a good element for Saturn, the planet that appeared to move the slowest. Iron, with its rust, is red, and Mars is red. Further, the war god must certainly used iron for a sword and spear. The others, we aren't quite sure. The alchemists were a secretive lot. Again, the most important goal for the alchemist was the knowledge of how to turn base metals, such as lead or mercury, into gold. We recall that Aristotle thought the metals were made of compressed vapors exhalations under the ground. The alchemists, basing themselves upon Aristotle, identified the dry vapor with sulfur, a non-metal, and the moist vapor with mercury, a metal, and thought that these two combined within the earth should create all the other metals. All that had to be done, so it seemed to them, was to recreate the way the gold had been produced under the ground, but do it above ground in the laboratory. Perhaps that's why alchemists' laboratories resemble dark and dank, smoky caverns. In their effort to ply nature for her secrets and produce gold in the process, alchemists came up with a dazzling variety of strange instruments and concoctions. We would find a good many familiar and some unfamiliar instruments in the alchemist's laboratory. They would be large round-bottomed flasks and smaller bottles, funnels, filters, great metal vats and furnaces, mortars and pestles and skills, all very familiar. But we'd also find a variety of oddly shaped devices. One of the most important was the alembic, a glass which looks like a squat bird with a tremendous long, thin beak. The alembic was used for distillation, a very important process of chemistry right down to the present day. Distilling is something like the process of reduction used in smelting, in that it separates substances that consist of more than one element into simpler or purer substances, but in distilling the separation does not occur because of a chemical reaction like the removal of oxygen from metal ore with carbon monoxide. The separation occurs by vaporizing using the heat of a fire or evaporation using the heat of the sun, one part of the compound from another. As long as one part of the compound vaporizes or evaporates more easily than the other, distillation can be used to separate them. So, for example, if you want to get pure water from salt water, you could distill salt water. You can make a very simple distillation apparatus to do just that. Add 1 tablespoon of salt to 3 cups of water. Stir until the salt completely dissolves. Taste it. Then put the salt water into a pan. Put a curved cover on it and heat until it boils. Let it boil for a minute. Then pull the pan lid off. Turn it over quickly and let it cool. Taste the liquid which has condensed and gathered on the lid. It is no longer salt water, but pure water. You have distilled water from salt water. While alchemist instruments may look quite unlike the sophisticated and shiny instruments of today's chemists stand on the shoulders, so to speak, of the alchemist. For the long, difficult process of discovering the elements, the alchemist's tools allowed from the beginnings of the kinds of processes by which the elements were eventually identified. Some people have the right idea, but go about it the wrong way. The alchemists had the wrong idea that they could turn lead into gold, but went about it in the right way. Discovering the right process for later chemists. In fact, the alchemists invented almost all the chemical apparatus used up until the 17th century. Yet it was not just the instruments that made an alchemist, but his concoctions as well. Not only was he busy designing various kinds of devices, but he was also brewing various mixtures by which he hoped that he could bring about the desired goal of transforming base metals into gold. And so we might find on this shelf some vitriol or Cyprus copper sulfate, white vitriol, zinc sulfate, aqua regia, nitrohydrochloric acid, arsenic, saltpeter, potassium nitrate, alum of Yemen, aluminum sulfate, burning water, alcohol, brimstone, sulfur, or sal ammoniac, ammonium chloride. We should note that the only 2 of the chemicals listed are elements, sulfur and arsenic. The alchemists did not discover many pure elements. They thought they already knew what the elements were: hot, dry, cold, and moist, or fire, earth, air, and water. It is very hard to find something you think you've already discovered, especially if you are mistaken, that is. But they did something else very important, which would allow later scientists to discover the real elements. The alchemists collected all kinds of strange chemical compounds and very carefully recorded how they reacted to being heated in various ways, either by themselves or with other compounds. That mercury or okay. Wait a second. We have an extra page here. Sorry about that. Okay, that was the step in the right direction. Some of the most important substances discovered by the alchemist must begun attempts at creating gold were acids, mainly sulfuric and hydrochloric and nitric acids. These words, the word acid comes from the Latin acidus, or which means sour, an appropriate name since acids in water solutions do taste sour. Acids have all kinds of strange and wonderful effects and are especially helpful in breaking substances down. The ultimate goal of the chemist, to get to the bottom of things, to find the ultimate simple elements, we have to take apart the more complex everyday substances. Acids help take them apart and sometimes put them together in strange and mysterious ways. Here is one of the mysterious ways. Put 3 tablespoons of vinegar into a tall glass, then add 1 tablespoon of baking soda. You should do this on the kitchen counter so you can easily mop up the mess. Exactly. What happened? Where did all the bubbles come from? Was there air trapped in the vinegar and the baking soda in both? If you can do the same experiment with a small neck bottle and a balloon, put the vinegar into the bottle, pour in a tablespoon of baking soda, and quickly put the balloon over the top of the bottle. Now you will see that air somehow is being produced or released from the ingredients. How do we know? The volume of air increases. That is, the total amount of air increases. The original volume of air equals the air in the bottle. New volume of air equals air in bottle plus air in balloon. If we can measure the volume of the air, we can make an equation so that we can know how much air was produced by adding different amounts of vinegar and soda. Vinegar is an acid with which the alchemists were very familiar. Although to be exact, vinegar contains acetic acid. In many cases, you can be sure that alchemists did many experiments like the one you just performed. Such experiments produced something that you caught, but the alchemists did not see, even though it was right in front of their noses or under their beards, as the case may be. Their brilliance too had kept them from advancing in the knowledge of nature. What did they miss? Air. Not only did they have a way to trap the air they escaped from the chemical reactions, but they didn't think it was worth their notice. So while alchemists took us a long way toward chemists and the periodic table, the end was still far off. Oddly enough, the key to unlocking the mystery of the elements, and hence the mystery of the periodic table, was to discover the strange and marvelous properties of air. But that would take some time and quite a bit of effort, as we shall soon see. All right, that is the end of chapter 4.